Alrighty, let's see what we got. It's gonna be an easy. I previously done this. Pretty small number. Alright, let's see. Add binary. Given two binary strings A and B, return their sum as a binary string. 1, 1, 1 is 1, 0, 0. Sure. This is 3, this is 1, this is 4 in binary. 2, 8, 10, 10 plus 1, 3 plus 8, 11. 10 plus 11 is 21, so 16, 4, and 1. Okay. Alright, cool. When we do addition, it's generally right to left. Carrying over, right? Carrying over 1 plus 1 is 1, 0. I guess in Python it would be going index by index. I'm gonna quickly make A and B be such that A is the longer string. So I'll do something like if the length of A is greater than the length of B, then A B swaps. So I'm just making it consistent, so I know if they are not the same length, then A is the longer length. So I will iterate through the indices of A backwards. Maybe it's the other way around. Maybe I want to have A be the shorter length string. Because I know if I have a shorter length string, then I just go through the end of it. And then all the kind of remaining characters, remaining bits are coming from the other string. Is that right? Alternatively, you can try to like somehow make them the same length by adding zeros to the front end of the string. To be honest, I wonder if you can just use the. I wonder if you should just use the. I think Python has a conversion thing. Return their sum as this binary string. So I wonder if there's print integer of A. I think it converts a string into the bit. Okay, converts it to an integer, and then I can use modular arithmetic to get the last digit of each integer. Okay, I think that might work. So A and B, I convert them to integers. And so integer, decimal integer, not binary integer. So then I'll just use a loop. I'll do something like while true. I'll go ahead and get last digit, which will be the bit of each number using modulo. So since this is in decimal, then I'll use something like a bit is going to be a mod 10. So taking the remainder divide by 10. Divide by 10 to get the remainder. B bit is going to be b mod 10. And I'm just going to have to store it backwards, right? Because the thing I'm going to get here is going to be, this is the last digit, then I don't know how many digits there are, so maybe I'll use an array. B array is empty. So I think it's something like 1 plus 1 is 0. So is it XOR? Yeah, I think it's XOR. If you do the last bit plus the last bit, you'll get a 0 if it's both ones, and you'll get a 0 if they're both zeros. But if either of them are 1 or 0, then you should get a 1 as the summation of that last bit. So I think it's XOR. So it's something like some bit is going to be a bit XOR is, I think it's that character. XOR operator Python. I think it's the caret. Okay, yeah. And then I'll append that to the B array. And this is in the wrong order. It's in reverse order, but I'll just reverse at the end. And then the carry is if they're both ones. So if they're both ones, then it carries over. So I think I need a carry bit. So I think this should probably be, how does the carry bit carry? So if there's a carry over 1, 1, 1, 1. So I think it may be XOR again with the carry bit. Because if there's a carry over 1 added to any ones, then it actually ends up being a 1, right? And then the carry bit changes to be what? So if it's 1, 1, 1, there's a carry. If it's 0, 1, 1 is a carry. So at least 2 of the 3 things needs to carry. Needs to be 1s in order for it to carry. Can I simplify the logic somehow? 2 of the 3 things needs to be a 1. So I can't just do it all in AND. So can I do reverse logic if only one of the things is a 0? Only one of the things is 0? No, if 2 of the things were zeros. Boy, the carry bit really. I can do it in 2 steps from trying to do it in 1 step. So I do A bit and B bit. One. No, it's not it. Has to be. It's 0 if they're both zeros. No, what am I doing? Can I do an AND on A and B? A bit and B bit? No. Huh. What's going on? So if it was like 1, 1, 0, 1, and there's a carry of a 1, 1 plus 1 plus 1 should give you the sum bit, or maybe this should maybe call it the last bit. Last bit is going to be 1, and the carry bit should be a 1. XOR and all of them should work for the last bit. And then carry bit should be 1, should be 1 here. As long as 2 of them are 1s. As long as 2 of them are 1s, or 3 of them are 1s. they're not all zeros, and they're not all zeros. Now, if they're two zeros, then what's going on? There's either 0, 1, 2, or 3 zeros, right? For the carry bit, A bit, and B bit. 0 zeros, 1 zeros, 2 zeros, 3 zeros. So if there's 2 zeros or 3 zeros, there's 2 zeros or 3 zeros. One zero. Oh, I do the summation, right? Yeah, I just do the summation. Oh my god. Logic. I was too in the mode of logical ands and ors and XORs. So if the sum of them is greater than 2, carry bit is equal to 1 if A bit plus B bit A bit plus B bit plus carry bit is greater than 2, else it's going to be a 0. It's greater than 1. Okay. And then the binary array, that's technically backwards, appends the last bit. And then I'll do a break here. I guess if the carry bit is, if they're all zeros, I think. If the carry bit's 0, A bit's 0, and B bit's 0, then that means I'm at the end of the thing. Wait, yeah, I think. Is that right? If A bit's 0, B bit's, yeah, that's right. I guess if they're all 0, then they just multiply to 0. No, I just do an AND, right? I do an AND. What do I check if they're all zeros? If I can do some sort of logic like 1 minus A bit times 1 minus B bit times 1 minus carry bit. If that equals 0, then break. Because if any of them if all of them are zeros, actually, sorry, this should be equal to 1. If all of them are zeros, then the multiplication is equal to 1. 1 times 1 times 1. If any of them are 1s, then it multiplies to 0. Yeah, I think that's right. And then I do something like reverse the binary array and then convert it to a string. So that'll probably be something like return join binary array backwards. That's the syntax. Or just could not stop the loop. Oh, shucks. Shucks cahoots. Yeah, it's got timeout. Yep. Let's do, let's go and do this loop plus equals 1, and then I'll do something like print the B array. Oh, it's because I'm not actually removing. Yeah, should be removing the last bit as well as getting it. So a mod 10. So something like a bit, b bit equals a mod 10, b mod 10, and then a and b equals a mod a divided by 10 to get rid of it, b divided by 10 to get rid of the last digit. Sequence item 0 expected string found, not int found. Oh, think. So I have an integer array that I want to convert to a string. Right. I think, what was the syntax? I think it was like join. Oh, it was map. Yeah, it was map. I need to map the array to a string array. So map pass, I think there's multiple versions of map, but you can pass an array and a data type, and then it converts every element of that array, or you can use any sort of iterator data type or data structure. Any data structure that has an iterator kind of, so you can use set or something, and it converts every element of that data structure to your converting thing. So yeah, that's right. Or it could be the other way around. Should be map string. Yeah, oops. This should be the array is the second parameter. Easy, huh? Easy. Okay. Okay, so this one answered it correct. This one answered it very wrong. 2, 1, 1, 1, 1, 0. Carry the 1. I think I see. Do I see? The carry bit should have been a 1 there. Carry bit should have been a 1 at the very, adding 1, 1. Adding 1 plus 1, the carry bit somehow didn't become a 1. Oh. So added 1 plus 1 plus no carry. No, ended here. Ended with 0, 0, 1. Okay, yeah. This is I shouldn't be doing this. It should be 1 minus a, just the remainder of whatever is left. 1 minus b. Yeah. I don't think this is very fast. Yeah. Do 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 do. Yeah, it's not very fast. This thing is not good. These are operations that are O of n, I think. Converting it to an integer. I think I just need to iterate through the indices of the string. Yeah. Same logic. Same or similar logic. Okay, and even this thing, reversing the array, is also pretty slow. It's going to be O of n. And there should be a much faster O of n method, I think. Okay, so same logic with just string indexing. So I need to iterate through the indices of A and B. I guess I probably should iterate over the indices of the shorter length string. So let's assume that A is the shorter length. So if length of A is greater than length of B, then I'm going to make A and B swap. So iterating backwards over the indices of A, it'd be something like n equals length of A if or for every index, it's just a k in range n minus 1, negative 1, negative 1. Is that right? Maybe I make use of the fact that I can just use negative indexing to go backwards. So I'll just say actually go from 0 to n. And the last bit for A is going to be A at negative k, maybe? At k minus 1, negative k minus 1. Same thing for B bit, is B at negative k minus 1. And then I'll do the same logic here. So I'll probably have a carry bit. The way I want to do this. I guess I map it. Map. Or do I want to map it? If this thing is equal to 1, then make it 1. Else 0. 1 if this thing is equal to 1. Else 0. And then last bit equals A bit XOR B bit XOR carry bit. And then carry bit equals 1 if the sum of them are greater than 1. Else it's 0. I still need a binary array. So, gosh. I still need to construct it, right? Still need to construct it. Guess I can construct it using without using mapping. If I just add in I just add in the string itself that I want? So barray appends 1 if the last bit equals 1, else it'll append a 0 character. And then if 1 minus, oh man, I wonder how slow this is actually. 1 minus a, 1 minus b. I don't mean to do this actually because going over the indices, I know that this is all going to work. Maybe, actually, I think I maybe want to just use all the letters. So A is the longer string. So here if something like, yeah. So A is the longer string at this point. So I need to worry about whether or not this is out of bounds for the B string. So the B string this would mean if K is less than the B length, and if it is, then I can index into it. Otherwise, I'm just going to assume it to be 0 because it's past the end of that string. And then I need to do one last append of the carry bit. And then I'll do something like return join B array backwards. Okay, I don't know. This might still be slow. Alright. Or it could be randomly fast enough. I don't know. Interesting, kind of. So got A to be the shorter length. No, A is the longer length string. Maybe I should just say A length here. B length is shorter, so I know that indexing backwards through A is always going to work using negative indices, where -1 is the last index, or -1 is the last index in the A string. And then therefore I need to have a out of bounds index check for accessing that index into B. Otherwise they're going to be just the corresponding kind of last bit or second last bit or third last bit in both strings, something like that. Logic for the carrying, logic for the value of the last bit, just using XOR, logic for whether or not there's going to be a carry over bit, and then appending basically the last bit as a character at this point. Like here, this is integer kind of logic here. Integer values. And then appending the carry bit one more time. And then converting the integer array back to a string. Okay, yeah. All right, I don't think I'm going to do this in Java because I think Java is just fast enough that, but whatever you do is probably easy. So here's summary for Python. Use indices to work backwards through the binary strings. Use a for loop that iterates over indices of longer string with bounds check for shorter string. Gets the values in integer form, for the corresponding, for the bits at those indices, at that index, and does kind of does the appropriate logic to add two binary values, two binary bit values. Also need to have a third value for the carryover bit, and incorporate that into the logic. So basically, you should have A plus B plus C as your bits, adding to some last bit or some carry bit, and some kind of last bit, like 1 plus 1 plus 1 should equal 1, 1, right? Where the carry bit is 1 and the last bit is 1. Make sure logic works there. Make sure whatever logic used works for all cases. I used just XORs to make this simplified, but in theory you could just use a bunch of if statements if you wanted to be careful about it. And then carry bit is based on the sum of them being greater than 1, so if 2 or more of them are going to be 1s, then there's just going to be a carry. Time complexity is going to be O of n, where n is the length of the binary strings, since it iterates over all bits of the string. And then base complexity, this can be O of n as well, since an array of bits is used to temporarily store the values before converting it back into string form, since array of integer bits